Hello everybody, this is Banerjee, instructor of Mathematics Tutorials M1. Now I have to discuss previous question paper from the seniors. In this there is part A, part B. In part A, for first question, there are 7 2 marks questions, and the part B there are 7 questions which carries 4 2 marks questions. We have to answer for that 4 questions. Now we discuss about part A with 7 questions containing for first question. In that first question A, if u equal to sin inverse of x minus y, x equal to 3t and y equal to 4t square, find du by dt. Given u equal to sin inverse x minus y, x equal to 3t and y equal to 4t square, for this we have to find out du by dt. We know that du by dt means dou u by dou x into dx by dt plus dou u by dou y into dy by dt. We have to find these values first. For this we have to find one by one. Dou u by dou x means dou by dou x of sin inverse x minus y. We already know dy by dx of sin inverse x equal to 1 minus root over 1 minus x square. Like this we have to find this. By solving this we get dou by dou x equal to 1 by root over 1 minus of x minus y whole square. And similarly dou by dou y, in this we differentiate with x, in this we differentiate with y, then as like we get dou by dou y equal to minus 1 by root over 1 minus x minus y whole square. Now dx by dt equal to, we already know x equal to 3t, by differentiating it we get 3 because d by dx of x equal to 1 and dy by dt equal to, we know that y equal to 4t square. By differentiating with t square we get 2t, it is 4 into t equal to 8t. Now we get 4 values. By this we have to find out du by dt equal to dou u by dou x into dx by dt plus dou u by dou y into dy by dt. Substitute remaining values in this, then we get final answer 3 minus 8t by root over 1 minus of here xy whole square, but in we replace x equal to 3t y equal to 4t square, then we get 1 minus of 3t minus 4t square whole square. Now second question B, expand in powers of e power x and y of x and y up to second degree term. Given function was, we have to replace f of x y. We consider e power x and y. We have to expand up to second degree term. Now we have to change this into second degree term. Let us take count point x y is origin 0, 0. Now at f of 0, 0 we have to find that f of x y equal to, we get 0. As later we find out for fx, that means dou by d by dx of f of x e power x and y. By solving this we get e power x and y. At 0, 0 we got 0 and f of y at 0, 0. By solving this we get e power x cos y. Then at 0, 0 we get 1 into 1, that means cos 0 equal to 1, that's why 1 into 1 equal to 1. F of x equal to double x, that means we have to differentiate, double differentiate d square of e power x sin y by dx square equal to d by dx of f of x. We already find out f of x, that means d by dx of f of x. We have to take this. By again solving this we got e power x sin y. At 0, 0 we got 0. F of double y equal to d square e power x sin y by dy square equal to d by dy of fy equal to d by dy into, we already got fy means e power x cos y. By differentiating with y we get minus e power x sin y. At 0, 0 again it becomes 0 and f of xy, that means we have to replace as I differentiate with x and differentiate with y. I differentiate with x d by dx of d by dy of e power x sin y. By differentiating with y function we got e power x cos y, and again we differentiate with x, then we got e power x cos y only. At 0, 0 we got 1. So we know that at for the second degree term the exponential form is f of x equal to f of 0, 0 plus 1 by 1 factorial into x into f of x of 0, 0 plus y into f of y of 0, 0 plus 1 by 2 factorial of x square f of x 0, 0 plus y square into f of double y 0, 0 plus 2xy fxy 0, 0. By substituting this we get the final answer y into 1 by x. That means for the expansion form of e power x and y in second degree term is y into 1 plus x. C. Find the integral factor of differential equation. Here we given differential equation dy by dx plus y secant x plus tan x. dy by dx plus y secant x equal tan x equation. We know that it is in the form of dy by dx plus p of x into y equal to q of x. That means we are observing here p of x means secant x, q of x means tan x. For this form, for the integral factor is e power integral p of x dx. Now we have to replace in p of x secant x. Integral factor equal to e power integral secant x in dx. We already know in the integration, integral secant x dx means log mod secant x plus tan x. That only I substitute in this. Integral secant x dx means log mod secant x plus tan x. By replacing down, that means I replacing secant x plus tan x with e. We already know that e power log b base e. I want to replace b, that's why we get here b power log e base e, that is b. Like this I replace, I got integral factor equal to 1 by mod secant x plus tan x. It is integral factor. Now define the equation orthogonal trajectories. So this is for definition. That means we know that any curve which cuts every member of a given family of curves at right angles. That means the condition m1 m2 equal to -1. This is the condition. At this condition, it got orthogonal trajectory of the family. If the curve should intersect, the angle between the tangents at every point of intersection is 90 degrees, must be 90 degrees, because here m1 m2 equal -1 means it must be perpendicular slopes. That's why the angle between the tangents at every point is 90 degrees. Coming to the fifth question, find the particular integral of differential equation. Given differential equation was d square plus 1 into y equal to x cube. Here given, we got to find a particular integral. Particular integral means we already did form. It is in the form of some x equal to x power m. For this form, the particular integral is 1 by f of d into x power m. Here f of d means the given function d square plus 1. X power m means here again given question x cube. For this I replaced it in inverse function f of d of inverse into x power m. If f of d in place of 1 plus x form, then 1 plus x of inverse equal to, we get alternatively 1 minus x plus x square so on. If f of d equal to 1 minus x, then 1 minus x inverse means we got as all plus forms 1 plus x square so on. Now we have to do it is, if we see this, now d square plus 1 into y equal to x cube, where d equal to d by dx. We already know that. Now we find the auxiliary equation which was the roots. Auxiliary equation is d square plus 1 equal to 0. For this equation we have to replace with 0. Then we equating d square equal to -1, we already know in complex theory I square equal to -1. So I replace -1 in place of I square. I got d equal to plus or minus I. So here common factor was e power ax into c1 cos x plus c2 sin x. Because here we got I. We have to find particular integral. That means 1 by f of d into x power m. I replace in f of d d square plus 1 and x power m x cube. I inverse this 1 plus d square of inverse equal to x cube. Here if you see this by expanding this form in alternatively, here the power x power 3. So whatever there in this power, that much value less than is there in this equation. If you see this, d square whole power square means it's d power 4. 4 is greater than 3, not less than 3. That's why we should not consider these all values. We only consider 1 minus d square. Now 1 minus d square into x cube. Multiply it, x cube minus d square into x cube. Here d means you already know this. Find out. D means what? D by dx. That means differentiation. So here d square into x cube means d into d by dx of x cube. We differentiating one function. Then we get 3x square. Again we differentiating function. We get 3 into 2x. That means 6x. So we got particular integral was x cube minus 6x. For suppose if they ask total solution, then we have to find out like this. Total solution was pi plus cf. Pi means the given question we already got it, x cube minus cx. CF means e power ax into c1 cos x plus c2 sin x. We already done it. If you see that in that is a a got, we know it is in the form of a plus or minus ib. Here a means real root, b means imaginary root. We got imaginary root 1, that's why we got cos 1x plus sin 1x. A c1 c2 constants. In a, here not value is there, that means a equal to 0. That's why I take it e power 0 into c1 cos x plus c2 sin x plus x cube minus 6x. Then finally we got e power 0 means 1. So finally the solution, total solution was c1 cos x plus c2 sin x plus x cube minus cx. Sixth question. State the general form of Cauchy's linear equation. The general form of Cauchy's linear equation is this: x power n into d power n y by dx power n plus k1. That means constant. You have to take it k1 or a1 or b1, any value. This was constant. K1 into x power n minus 1 into d power n minus 1 y by dx n minus 1. Like so on, we get kn minus 1 into dx dy by dx plus kny equal to x, where x is the function of x is called Cauchy's linear equation. G. Test the convergence of the series. Here given function sigma of n by n plus 1. We have to find out this is convergent or divergent. Now let's take suppose un. We consider un equal to n by n plus 1. We have to apply 1 power n. U point by 1 power n equal to n by n plus 1 whole 1 by n. By common this we get like this: 1 by 1 plus 1 by n whole power 1 by n. By replacing we get 1 by of 1 plus 1 by n whole power 1 by n. Now apply limits, which was n up to infinity. Then we get limit up to infinity, which was un power 1 by n equal to limit n infinity 1 by 1 plus 1 by n whole power 1 by n. By replacing infinity we got finally 1. Here 1 means it is equal to 1, which was the function un. If un is less than 1, then only it is convergence. If it is equal to or greater than 1, then it must be divergent. So from the given answer we get it is not convergence of series. Now coming to part B. In second question A, if u equal to x plus y plus z, uv equal to y plus z, uv double equal to z, show that dou of x by z by dou of uv double equal to u square v. We have to find this, prove the theorem. So from the given question, u equal to x plus y plus z, uv equal to y plus z, uv double equal to z. We have two types of variables. One was uv double variables and x y z variables. We know that according to the Jacobian rule, dou of x y z by dou of uv double means must be considered with one differentiable. We have to replace with one differentiation. So first we replace with x. We got dou x by dou u, dou y by dou u, dou x by dou v, dou x by dou z, dou w. Like that we have to replace y z, dou y by dou u, dou y by dou v, dou y by dou w. Like this we got form. Now we have to find equations in x, y, z. So that's why, because all the equations are in replaced with x, y, z functions. So we must find uv as a term constants and x, y, z take as a constant. Then we get, here already we get z equal to uv. It's considerable. Like taken as equation 1. Coming to this uv equal to y plus z. We already know z equal to uv. So replace in z place uv. Then we get like this, y equal to uv into 1 minus w. It is considered second equation. Now take this u equal to x plus y plus z. We already know y plus z means uv. So I take this condition, u equal to x plus uv, x equal to u minus uv, x equal to u into 1 minus v. I took this is third equation. Now you see we got three values x, y, z. From this we find this form which was given from the question, LHS. LHS equal to dou of x by z by dou of uv. We know x means u into 1 minus v, y means uv into 1 minus w, z means uv. By differentiating these values, we got like this. By solving this, we got finally u square v. So finally we proved that dou of xyz by dou of u double equal to u square v. Hence proved. Coming to the second question B. Verify Euler's theorem for f of xy equal to tan inverse y by x. We know that generally we have to find is, let us consider kx ky, that means constant. When we apply kx ky, then we find out this in 3 plus of y ky, in 3 plus of x kx. Then we got constants cancel and we again replace the value tan inverse y by x. That means here k power 0 equal to 1. It is homogeneous equation of which the degree was n equal 0. To verify Euler's theorem, we consider in the form like this: x into dou z by dou x plus y into dou z by dou y equal to nz. Suppose let's take this tan inverse y by x equal to u. U equal tan inverse y by x. Tan u equal to, we have to replace this, tan u equal to y by x. Tan u equal to y by x. Let's take z equal to tan u for suppose. Then z equal to tan u means z equal to y by x. Then x into dou z by dou x plus y into dou z by dou y equal to nz. We already know degree of equation n equal to 0. So we have got 0 value. Here z means tan u. We have differentiate with x and replace it y. So we differentiate with x and y. We got x secant square u dou u by dou x plus y secant square u dou u by dou y equal to 0. Then finally you got the answer what? X into dou u by dou x plus y into dou u by dou y equal to 0. It means it is in the form of Euler's theorem. Hence Euler's theorem is verified. Now coming to the third question. In third A, find the maximum and minimum value of function. Given function was this. Let us consider f of xy equal to x square plus y square minus 2x. Now do differentiate with, represent with x and represent with y and equating with 0. We got dou f by dou x equal to 2x minus 2. By equating with 0, we got x equal to 1 value. And we differentiate with y value, we get 2y. Equating to 0, we get y equal to 0. We got a common point, x comma y equal to 1 0. Now take r equal to, that means we have to tip this r as t. R means dou square f by dou x square. S means dou square f by dou x dou y. T means dou square f by dou y square. By solving this, we get r value equal to, s value equal to 0, t value equal to 2. Now we find the value of rt minus x square. Rt minus x square equal to, r means 2, t means 2. So 2 into 2 minus 0 whole square. We got 4, which 4 means greater than 0. And we already got r equal to, it is also greater than 0. We have one condition. If rt minus x square greater than 0 and r greater than 0, then the function is minimum at point which what we got 1 0. At this point the function is minimum. That means we got the minimum function at point 1 0. Now replace it in xy form, then we get minimum value. It was minus 1. So the minimum value of the function is minus 1. Coming to 3b. A rectangle open box of capacity 32 cubic units is to be prepared. Find the dimensions of the box to minimize the cost of painting outside of the box. In given question, we have to take for the rectangle which was given in cubic, that means it must be a volume. So we consider x, y, z units be the edge of the box, that means length, breadth and height, and s be the surface area. Then as per the given question, we get x, y, z volume of this cubic equal to 32 cubic units, and area, required area was generally 2xy plus 2yz plus 2zx. But as per the given question, which was a rectangle open box, we have to took one side. Then we get s equal to xy plus 2yz plus 2zx. Let's take phi equal to xyz minus 32. Let's take a function xyz minus 32 and s equal to xy plus 2yz plus 2zx. Now consider whole function f of xyz equal to phi plus lambda s. This lambda is constant, for what value we have to took. Now replace phi and s with given values. We got like this f of equation. Now for this equation we have to differentiate with x and equating with 0, and we have to differentiate y and equating with 0, and we have to differentiate with z and equal 0. Then we got 3 types of values. For these 3 types of values we have to took this. We have 3 types of values. By solving 1 and 2 we get the form x equal to y. So we got the equation by solving 1 and 2, x equal to y. But here we also got z equal 0, but we could not considerable. If z equal 0, the length breadth also 0, so it's not considerable. Now took 2 and solving 2 and 3 by replacing x equal to y. Then we got one equation which was x equal to z. We got x equal to y and x equal to z. That means x equal to y equal to 2z. Now take the given question x with z equal to 32. By replacing we take x equal to y and z equal to x by 2. We got x cube equal to 64, which is 4 cube, x equal to 4. We got x equal to 4. That means y equal to 4. Now we find z value. X equal to z. That means 4 equal to z, z equal to 2. Finally, we got dimensions x equal to 4, y equal to 4, z equal to 2. This is the third question. Now coming to the fourth question. Solve 40a. Solve x log x dy by dx plus y equal to 2 log x. Given question is this. We have to solve this function into solution, general solution. Also, I divided x log x on both sides. Then I got dy by dx plus y into 1 by x log x equal to 2 by x. It is in the form of dy by dx plus p of x into y equal to q of x. That means by comparing we got p of x means 1 by x log x, q of x means 2 by x. Now we find integral factor. Integral factor means e power integral p of x in dx. We know p of x means 1 by x log x. By replacing this we get e power integral 1 by x log x dx. Now I took log x equal to t, then 1 by x dx equal dt. So I got in this replace 1 by x in dx means dt, log x means t. Then I got function log t. By replacing t at down and d and at power, then I got value t. T means log x. So I got integral factor log x. Then the general solution was y into integral factor equal to integral of q of x into integral factor dx plus c. So integral factor means log x. Q of x means as per the question 2 by x. 2 by x into log x into dx. Now I consider log x equal to p. 1 by x into dx equal to dp. By solving this, I got the general solution. The required solution is y into log x equal to log x whole square plus c. This is the required solution. Now coming to 4th b. Solve x square minus 3xy plus 2y square into dx plus x into 3x minus 2y into dy equal to 0. So we have to solve this function as per the general solution. I took it is equal to minus function. Then I got x square minus 3xy plus 2y square into dx equal to minus of x into 3x minus 2y. I multiply into minus, then we get x into 2y minus 3x into dy. By commoning x square in both the terms, I got 1 minus 3 of y by x plus 2 into y by x whole square into dx equal to 2 into y by x minus 3 into dy. I cancel the x square. Then I replace down denominator and numerator. Then we got dy by dx equal to 1 minus of 3 into y by x plus 2 into y by x whole square by 2 into y by x minus 3. Now I took let y equal to y vx. If y equal to vx, then dy by dx equal to first integration with x. Then I got v plus integration with differentiating with vt. So by differentiating, I got v plus x into dy by dx. We already know that it is in the form of uv. dy by dx of uv equal to v into v dash plus u into v dash. Now replace dy by dx as this. V plus x dy by dx equal to this function. I replace minus of function. Then I got x dy by dx equal to 1 by 2y minus 3. Now by fractionalizing, then I got 2a minus 3 equal to dv equal to dx by x. Now integrating on both sides. On integrating both sides, we got the perfect solution, which was y square minus 3xy equal to x square into log x plus c. This is the required solution for the given question. Coming to fifth sum. Fifth A. Show that the system of confocal and coaxial parabolas y square equal to 4a into x plus a is self-orthogonal. This is a very important question. Given equation was y square equal to 4a into x plus a. Let us consider this is required for first equation. Differentiate with x on both sides. Then I got 2y into dy by dx because it's a variable equal to, by differentiating x I got only 1, so 4a. dy by dx equal to a by y. A equal to y by 2 in dy by dx. You got a value na? Now put this a value in this equation, first equation. Then you got like this, y square equal to y into dy by dx into 2x plus y dy dx. This is second equation required. That means you got whole the function in xy terms. Now for suppose replace dy by dx equal to minus dx by dy. That means you already know m1 m2 equal to minus 1. So m1 means dy by dx, m2 means minus dx by dy. That's why we have to replace dy by dx equal to minus dx by dy. Then we got function like this. So a function was come. That means as per the given replacement of question 2, equation 2 got, that's the equation was 3 in got. So by replacing this also, we are already coming y square equal to y into dy by dx into 2x plus y dy by dx. By observing, we got these are the orthogonal trajectories. That means perpendicular with 90 degrees. Hence family of curve is self-orthogonal. Coming to 50b, a body originally at 80 degrees cools down to 60 degrees in 20 minutes. Temperature of the air is 40 degrees given. What will be the temperature of the body after 40 minutes from the original? We know that general form was if theta naught is the temperature of the surroundings, which was air, and theta that of the body at any time t, then d theta by dt equal to minus k into theta minus theta naught, where k is constant. In the given question, the given theta naught is 40 degrees, which was temperature of air. Now integrating by replacing down, we integrating on both sides. Integral d theta by theta minus 40 equal to minus k into integral dt. I got the function log of theta minus 40 equal to log of c into e power minus kt. Now I cancel the log function, and we got theta minus 40 equal to c into e power minus kt. If as per the given question, what at initially at t equal to 0, it is 80 degrees and cools down to at t equal to 20 minutes, we got 60 degrees. That means temperature decreases. At initial t equal to 0, theta equal to 80. By solving, taken into equation 1, I got c value 40. At initial t equal to 20 minutes, then theta is down to 60 degrees. By replacing in equation 1, I got k value 1 by 20 into log 2. We got c value, k value, and already they given find out the temperature at t equal to 40 minutes. From this, we have to find out the original temperature. At t equal to 40 minutes, theta minus 40 equal to c into e power minus kt. We already got c equal to 40, k equal to 1 by 20 into log 2. By replacing it at t equal to 40 minutes, we got final answer theta equal to 50 degrees. This is the required original temperature for required solution. Coming to the sixth question, solve d square plus 2d plus 5 into y equal to x into e power 2x. Given equation was this. Let us consider auxiliary equation d square plus 2d plus 5 equal 0. So it is not directly solved in factorization. That's why I took this form minus b plus or minus root over b square minus 4ac by 2a. By solving this form, I got complex roots minus 1 plus or minus 2a. Here minus 1 means real root, 2 means complex root, imaginary root. Then common factor is e power minus x into c1 cos 2x plus c2 sin 2x. Now coming to the particular integration. So particular integration means 1 by f of d into function. So the question given function was x into e power 2x. That's why I took this 1 by d square plus 2d plus 5 into x into e power 2x. Now for this form I have to replace, when this form comes e power 2x form, then I took replace as d as the what was the value as given in the e power ax. So I want to replace d equal to 2. Then I got x by 13 into e power 2x. Then final solution was y equal to c of plus py. We got c of means e power minus x into c1 cos 2x plus c2 sin 2x. Pi means x by 13 into e power 2x. Coming to the 6th b. Solve x square d square minus xd plus 4 into y equal to cos log x. For this question, we have to replace this function with d function. So put x equal to et. That means t equal to log x. When differentiating this, we got x dy by dx equal to dy, which is the function means d by dx of y. So we consider x d of y equal to dy. And x square d square by dx square means d into d minus 1 into v. By replacing these values in this function, we got d into d minus 1 minus t plus 4 into y equal to cos t. By solving this, we got general equation d square minus 2d plus 4 into y equal to cos t. Now I took auxiliary equation which was d square minus 2d plus 4 equal 0. By solving this, I got imaginary roots, which was 1 is the real part and root 3 is the imaginary part, 1 plus or minus I root 3. So d equal to 1 plus or minus I root 3, y equal to CF plus PI, the general solution. So we have to find CF and PI. CF means e power ax into c1 cos px plus c2 sin bx. Here a value means 1. So we take function x equal to e power t na, that's why we took in x place replace t. E power t into c1 cos, we got b value root 3. So cos root 3 t plus c2 sin root 3 t. Coming to the pi, 1 by f of d into cos t. F of d means t square minus 2t plus 4. Coming to this, when we got the form like this cos x ax by d square form, then we must took replace in d square place equal to minus a square. That means what was value in the between cos x, that value we have to take as minus a square. Now for the given question, we know cos t means a value is 1. So we have to replace d square as minus 1. By replacing this, we got 1 by 3 minus 2t into cos t. For this, we have to rationalize with function 3 minus 2t rationalizing, we get 3 plus 2t by 3 plus 2t. Then 3 plus 2t by 9 minus 4d square into cos t. We know that d square means minus 1. By replacing it, we get 3 plus 2d into cos t by 9 plus 4, which was 13. So I got pi equal to 3 cos t minus 2 sin t by 13. The required solution was y equal to e power t into c1 cos root 3t plus c2 sin root 3t, which was cf. And pi is 1 by 13 into 3 cos t minus 2 sin t. And we know that t means x equal to e power t, t means log x. E power t means x, t means log x. By replacing the function, we got general solution. This is the general solution. Coming to the 7th question. 70a. Solve d square plus 1 into y equal to x by the method of variation of parameters. So this is like the upper questions we already done in previous questions. So again coming to auxiliary equation is d square plus 1 equal to 0, d square equal to minus 1, d square equal to I square, d equal to plus or minus I. Then we got c of p is c1 cos x plus c2 sin x. It is in the form of x equal to x power m. Then pi equal to 1 by f d into x power m. We know that if f d is replaced with 1 plus x, then form like alternatively 1 minus x plus x square minus x cube, so on. If f d equal to 1 minus x, then it is ordered in 1 plus x square, so on. Now we consider pi equal to 1 by d square plus 1, which was f of d into x power 1 x. By replacing inverse function, we got 1 plus d square whole inverse into x. That means 1 minus d square plus d square whole square. Alternatively, here the power is 1. So I require only 1 below, less than 1. That means x power 0, d power 0. Here d power 0 means 1. That means this 1 is represent d power 0. So I took only one value. I don't consider these values. 1 into x is x. This is the pi. Finally we got y equal to c of plus pi. c1 means c1 cos x plus c2 sin x plus x. Coming to 7 to b. Solve the simultaneous differential functions, differential equations dx by dt equal to 7x minus y, dy by dt equal to 2x plus 5y. This is the required question. Given these two, from these two we have to find out the real solution. So we know that dy by dx equal to dy by dt by dx by dt. I consider like this. Then I got 2x plus y by 7x minus y. By take common x, I got value 2 plus 5 of y by x by 7 minus y by x. Let considerable y equal to vx. And then we got dy equal to v plus x into dy by x. So I replace the function as this, like this. Then I got x into dy by dx equal to v square minus 2v plus 2 by 7 minus v. So I rationalize it. Then 7 minus v by v square minus 2v plus 2 into dv equal to dx by x. Now integrating on both sides, we got integral dx by x equal to integral 7 minus v by v square minus 2v plus dv. Let's take it is in the form of px plus q by ax square plus bx plus c into dx. Integration, we find this form. Then px plus q means what? A into d by dx of the required denominator function plus b. Now 7 minus v, let us consider px plus q means 7 minus v. 7 minus v equal to a into d by dx of denominator plus b. By solving this, we get minus v plus 7 equal to 2a into v minus 2a plus b. Now if you think you have to comparing in v function 2a equal to minus 1 and constant function b minus 2a equal to 7. Then we got a b values. Coming to this, find the solution, which was integral dx by x means log x plus c equal to integral 7 minus v by v square minus 2v plus 20v. We know 7 minus v equal to minus half into 2v minus 2 plus 6. By replacing a and b values, we got this function. So now took in the equation 7 minus v, we took this function in 7 minus v minus 1 by 2 into 2v minus 2 plus 6 by v square minus 2v plus 2 into dv. Now split into these functions, put constants outside, minus 1 by 2 integral 2v minus 2 by v square minus 2v plus 2 into dv plus 6 into integral 1 by v square minus 2v plus, I took into 1 plus 1 I take due to I considerable. If we see it is, by differentiating this, we got the upper function. That means it is in the form of integral f dash x by f of x and dx. That means log mod f of x plus c. So I took minus half into this function was log mod f of x, which was v square minus 2v plus 2 plus 6 into, I consider v square minus 2v plus 1 as v minus 1 whole square. So I got 1 by v minus 1 whole square plus 1 square in dv. Now coming to this, minus half log v square minus 2v plus 2 plus 6 into, it is in the form of 1 by x square plus a square. Its x function was v minus 1. For this function, we have to took 1 by a into tan inverse of x by a. 1 by a means here a is constant. If you see this, here a value was 1. That means its value constant. So I took 6 tan inverse of v minus 1. Now by took replacing these functions, I totally got log x plus c equal to minus half log mod v square minus 2v plus 2 plus 6 into tan inverse of v minus 1. If you consider, we already know v means y by x. So I replace minus half log mod y by x whole square minus 2 into y by x plus 2 plus 6 tan inverse y by x minus 1. This is the required solution for the given function. Now coming to the last models. Coming to the 8th question. 8a. Test the convergence of series. The given question was 1 by 4, 7, 10 plus 4 by 7 into 10 into 13. Like that so on series. Let us consider un equal to n square by 3n plus 1 into 3n plus 4 into 3n plus 7. Because for replace n plus 1 in n equal to 1, then you got 1 by 4 into 7 into 10. If you replace 2, 4 by 7 into 10 into 13. Like this. I took as sigma form. For the sigma I took un equal to this form, n square by 3n plus 1 into 3n plus 4 into 3n plus 7. Now by taking here n common, all these three equations, I got n into 3 powers 1 by n, n into 3 plus 4 by n, and 3 plus 7 by n. By cancelling, I got only un equal 1 by n into 3 plus 1 by n into 3 plus 4 by n into 3 plus 7 by n. Let vn equal to 1 by n. That means this 1 by n constant was vn. I take un equal to vn by this. By getting denominator vn, un by vn equal to 1 by this form. Now apply limits n to infinity. Then by applying limits you got the value 1 by 27. If you see this, it is less than 1 value. That means less than 1. So less than 1 at vn. Since sigma vn is divergent. If vn is divergent, then automatically un is also divergent. So we require the function was un is divergent. 8 becoming 2. Discuss the convergence of the series. X by 1 plus 1 by 2 into x cube by 3 plus 1 dot 3 by 2 dot 4 into x power 5 by 5. This is the required equation. Hence, you consider un equal to 1 dot 3 dot 5 so on 2n minus 1 by 2 dot 4 dot 6 2 so on 2n into x power 2n plus 1 by 2n plus 1. I consider un equal to like this form. And un plus 1 equal to 1 into 3 into 5 so on 2n minus 1 and 2n plus 1 by 2 4 6 into so on 2n into 2n plus 2 into so n plus 1 means here we got in t place n plus 1, that means 2n plus 2 plus 1. So I got 2n plus 3, x power 2n plus 3 by 2n plus 3. Now by cancelling un plus 1 by un, I got the final solution 2n plus 1 whole square by 2n plus 2 into 2n plus 3 into x square. Now I common n from this, then I got the equation 2 plus 1 by n whole square by 2 plus 2 by n into 2 plus 3 by n into x square. Now apply limit to the function. Then applying limit we got un plus 1 by un equal to x square. By considering Raph's test, if limit n to infinity n into un by un plus 1 minus 1 into equal to L, if un is positive term series, then sigma un is convergent when if L value greater than 1, and sigma un is converted as divergent when if L less than 1. For suppose we consider let the test fails if x square equal to 1. Then you take here the question was un by un plus 1. We find un plus 1 by un. So reciprocal. Un by un plus 1 equal to 2n plus 2 into 2n plus 3 by 2n plus 1 whole square into in x plus in x square we replace 1. So I got this. Finally, now apply Raph's test. Limit n tends to infinity n into un by un plus 1 minus 1. I replace this value in this. We solve it. So finally we solving we get limit n to infinity n into 6n plus 5 by 2n plus 1 whole square. By common n we got 6 plus 5 by n by 2 plus 1 by n whole square. So by applying n to infinity we got this value is 0. Then 6 by 4 we got final value. Here 6 by 4 means this is L value. L value is greater than 1. We already know that by Raph's test, if L is greater than 1, it is convergent. So, as per the given, once we replace this, if L is greater than 1, it is convergent, L is less than 1, it is divergent. we got the values L is greater than 1. So according to Raph's test, this series is convergent if x equal to x square equal to 1. For this we have to consider x square equal to 1 or x square less than or equal to 1 only. It is considerable. L greater than 1 and Raph's test is confirmed. If x square greater than 1, then Raph's test not confirmed. Its convergent is not confirmed. So we got divergent form when x square greater than 1. Only we got convergent if x square less than or equal to 1. Thanks for listening this. If any doubts in the next week, ask in the session. Thank you.